Hello everybody and welcome to the first video about linear algebra in our machine learning course. So machine learning is 80% math and the rest is programming. That's a fact. That's not a joke. So linear algebra plays like really a huge role in the world of machine learning and deep learning. So yeah. So what we are gonna see in this course, in this video, we're gonna talk about some notations and maybe some operations on matrices and vectors. So let's start. What's a matrix? A matrix is a rectangular array of numbers between square brackets. For example, this is a matrix. As you can see here, just two brackets and a bunch of numbers. So we call these rows from here. This is a row and this is a row. And we call these columns. This is column, this is column, this is column. So we have rows in matrices. We have rows and columns. This is another example, another matrix. So this is rows. We have here like 3 rows and 2 columns. Here 2 rows and 3 columns. So what's dimension of matrix? Simply what I just mentioned, which is rows multiplied by columns. When I say this, I don't mean like to actually multiply. For example, here you multiply 2 by 3, and you say, oh, okay, the dimension of a matrix is 2 by 3, 6. No, that's the number of elements. You write the dimension just like this: rows x columns, like that. That's the represent, and in that way you represent the dimension of a matrix. So for example, for the matrix, we're gonna see say that the dimension of this matrix is 2 by 3. This is 3 by 2 matrix. And in many cases, in many notations, we can note this. You can see here r to the power of rows x columns. That means that the elements of our matrix here or here are in the numbers set R, which is real numbers. It can be n, it can be any like set of numbers, but like usually R is the used one, so don't worry about that. So what's matrix elements? A matrix, let's say we have this matrix here as an example. The element is defined by the row and the number of the row and the number of the column. So for example, A, I, J. So the element in the ith row and the jth column. So for example, we want A, 1, 1. Most of people are gonna say like, okay, A, 1, 1. So 1, 2, this is 1, this is 2, 1, 2, 3. So we can 1, 1. So this is the one. But this is right actually, but not always. In math, usually matrix counting starts from 1. But in programming languages, usually it starts from 0. So you have to pay attention about that. Is it 0 indexed or 1 indexed? You need to pay attention. But mostly we're gonna use the 1 indexed here in math explanation. And when we go to a programming language, I will note whether we use 0 index or 1 index. Here we are using 1 index, so we can say like that 1, 1 is 12. So what's A3, 1? You can pause the video, think about that or count it, And yeah, so A31 is, no, you cannot say A31 because 1, 2, 3. There is no 3. So this is an error. We cannot say that. There is no element with the index I equals 3, 1. Okay. So what's vector? A vector is a special case of a matrix where the dimension of a matrix is n multiplied by 1. Here we say, for example, that the dimension of our matrix is 2 by 3. In the case of a vector, since it's n1, for example, we can say that a vector y is n1. In this case, n equals 4. So it's 4 by 1 matrix or a vector. Simply a vector. And we can note that as R4. So our numbers are in the set of numbers, the real numbers, and 4-dimensional. So 1, 2, 3, 4. So yi is the ith element of our vector. For example, if we want to say like y3, you just count 1, 2, 3. So it's 10. Of course, as before in the matrix, if you say 1, 6, for example, 1, 2, 3, 4, there is no 6 or 5, so it's an error. Of course, you have to pay attention. Is it 0 indexed or 1 indexed? And since we are just here in the presentation, it's always considered as 1 indexed. Now, some operations that we can do with matrices. The first operation, the most simple one, is addition. If we want to do matrix plus another matrix, how we can do that? Simply, here is the result. You might be asking, how did we do that? Simply, we take each element and we add it with another element with the same position as the second matrix. Here, the first matrix, we took the first element 1, 1, and here we took also the element 1, 1, and we add them together equals 24. Another example, we took this element 0, we add it with the element in the second matrix of the same position, the element with the same position, 0 plus 9 equals 9. And we did that with all other elements. So, you might be asking, wait a minute, what if the matrices don't have the same dimensions? So, for example, this. How do we add this? For example, we can say that, for example, 58 here. There is no 3 in the rows dimension of this matrix. So, how do we add the 58? Simply, no, we cannot. It's an error. To do matrix addition, both matrices that we are adding have to be with the same dimensions. Okay, next. So yeah, this is like a note I wrote here. Must be the same shape or dimensions. You can call it whatever you want. Scalar multiplication. So what is a scalar? Is just like a number. Scalar is a number, not a matrix, just any number. How do we multiply multiplication of a scalar by matrix? Simply by multiplying the scalar with each number in the matrix. 2 multiplied by 12, 24. 2 multiplied by 25 equals 50. 2 by 0, 0. 2 by 11, 22, and so on. So simple, right? So you might want to ask, what about division? If we divide by 2, not multiply by 2. Simply, Division like dividing by 2 is the same as saying that we want to multiply by 1 over 2, a half. So it's the same, and just the result would be just like dividing each number of the matrix in question by 2, and we have like 24 divided by 2, 12, and so on. It's easy, right? Okay, I think this is the end of this first video. I don't want to make it a long video. I hope you now have a general idea about what's a matrix, what's a vector, how to do a matrix addition, when we are able to do matrix addition, when we are not, when we are able to, we are always able to multiply or divide by a scalar, except if the scalar is 0, we cannot divide by that. It's a general rule in math. So yeah, thank you very much for watching this video, and see you in the next video.